Sedimentary rocks are very important to understand our Earth's history. By understanding the conditions under which sedimentary rocks form, geologists can often deduce the history of a rock, which includes the information about the origin of its component particles, the method of sediment transport, and the nature of the place where the grains eventually came to rest, which is also called the environment of deposition. For example, we know that areas like these one that you see in both of the pictures that are found in the southwest of the US were covered by a vast sand desert about 200 million years ago. And we know this thanks to the sedimentary rock record that is preserved, and also based on the knowledge about the rocks that make up the sedimentary rock record. I think this picture right here is in Sedona in Arizona, and this one is in Canyonlands National Park in Utah, in case you're curious. The environment of deposition is a geographic setting where sediments are being accumulated. Each site is characterized by a particular combination of geologic processes and environmental conditions. Some sediments, such as the chemical precipitates in water bodies, are solely products of their sedimentary environment. Other sediments originate far from site where they accumulate and are transported from their source by some combination of gravity, water, wind, or ice. At any given time, that geographic setting and the environmental conditions of a sedimentary environment determine the nature of the sediments that accumulate. Certain features give us clues as to what formed those rocks and how did those form rocks. What were the processes? We apply this knowledge of today's conditions that we have and apply similar process to past times to provide us with reasonable explanations for the formation of certain rocks. So I just want to say that in this that we're doing in applying today's conditions to the past times in order to give us explanations, we are using uniformitarianism, which again was a concept we covered in chapter 1, where the present is the key to the past. So sedimentary environments, or also called environments of deposition, are usually placed into 3 main categories, and those are marine, transitional, which means near the shoreline, or continental. Each of these categories has many sub-environments themselves. The image above, which is figure 7.23 of your book, shows a lot of examples of those sub-environments. And we will cover them, or some of them, in detail on chapters 13, 14, and 15 later in the semester. I do encourage you very much so to look at these pictures along with the description in that figure 7.23 of your book, and also check the next slide's graph over here. So this figure here is not from your book, but I like it a lot because it explains in detail some of those environments of deposition. It shows the characteristics of those environments, the organisms that are present there, the sediment type that they usually contain, the sedimentary structures that may be seen there, and we'll cover these structures in a little bit. And it will ultimately tell you what kind of rock typically forms in an environment such as the one that is listed. So you can use, for example, this figure along with this image right here and come up with an idea of what sort of environments make what type of rock. Many a times, as we have covered before, the energy of the transport agent is going to be a big factor. The time that it takes is going to be a big factor. The specific compositions of the waters are going to be a huge factor. Many different things make up the sedimentary rock, but there are clues within each environment of deposition that help you narrow down which types of rocks could form in them. So I recommend that you pause the video and that you see it in more detail, or that you look at the slides separately and look at this with more detail as well. I also wanted to mention a concept here of sedimentary facies. Sometimes along with continental margin, or along the continental margin, sorry, for example, there may be 2, 3, or more rock types that are being formed at the same time. Perhaps there's going to be a sandstone closer to the seashore, and then a mudstone further from it, but all still within the continental margin. And there may even be a coral reef limestone being formed in an area in between the sandstone and the mudstone. So all of these rocks may be getting created at the same time within a very small section of geographic section, I should say. So there is a lateral migration of sedimentary facies during the same time period. So each rock type is going to be a facies within that time lapse. So the facies are those sets of sediments that make up each of the rock types. All right, I'm not going to quiz you on that, but I might refer to it again later on, so I figured I would clarify that. Okay, so now we have looked at environments of deposition. Now we will look at sedimentary structures for a little bit. Sedimentary structures are also one of the aiding features that help us determine what the environment of deposition was. So again, everything ties together. So make sure that you review the last 2 slides well in detail. All right, so in addition to the grain size, the mineral composition, the texture, there are some sediments that exhibit a variety of structures that are often preserved within the rock record at any one location. Sometimes these structures are a reflection of the transporting medium that was used. Other structures are a product of the environment of the position only. If these structures are present in the rock record, they usually provide additional information that can be useful when interpreting Earth's history. So they're like a fingerprint or a signature of that environment of deposition. Almost all of the sedimentary rock will display bedding or stratification, which is what you're seeing in both of these images. These are a layering pattern that is nearly horizontal. A stratum is a single layer or bed, okay, stratum. The strata is a set of beds or layers. So, for example, let's take this kind of ridge-forming rock. That is one stratum, because it's one single layer. And then if we take the whole set of layers here, that's the strata of that specific site. Okay, so each stratum differs from the one above or below it. Again, like you're seeing in the picture on the right, you can usually tell each stratum apart from the other. These strata range from microscopically thin to tens of meters thick, usually, and are separated by what are called bedding planes, which are relatively flat surfaces which split 2 of the stratum apart. When those layers that make up the stratum are thinner than 1 centimeter in thickness, they are referred to as laminations. If they are larger, they are referred to as stratum or beds. Sometimes the stratum has laminations within it, made up from the same rock type and same environment, but with bedding planes in between, which means lapses of time in between depositions. So, because sediments usually accumulate as particles that settle from a fluid, most strata are originally deposited as horizontal layers. Sometimes, however, when they do not accumulate in horizontal beds, sometimes the beds are inclined to the horizontal, which we call cross-bedding. This is characteristic of sand dunes, for example, river deltas, and sometimes some of the stream channel deposits. And these usually help us identify ancient transport medium directions, for example. So if you look at the diagram on the left, you see an idealized system under which this could occur. On the top left, I should say. Well, I think I did say that. In this case, you have current from wind or from water, which is driven to the right. And the particles that are accumulating in the steeper side of that feature. So for the rightmost picture, for example, you see the first 4 or so strata appear to have the same direction of current. So they all appear as though the current was this way, but they are separating by these bedded planes. So that's why I know they're different stratum. But the strata that are above over here seems like the direction of the current probably changed. So this one right here appears as if though the direction changed. So they allow us to identify that paleo-ancient transport direction. Another special type of bedding are called graded beds. In this case, the particles in a single stratum change from being very coarse at the bottom to being very fine at the top. So that's why they're graded. And this is typical of environments where you have rapid deposition for a high energy water currents that slows down and later loses a lot of energy. So they are commonly associated with turbidity currents, which are masses of water that are filled with sediments. So because they're filled with sediments, tend to be denser than the surrounding water. And so they will move downslope along the bottom of a lake or an ocean, for example, and cause this big amount of to drop. First the coarser material, then the finer one. Graded beds are also typical in alluvial fans, which we will look at in chapter 13 in more detail. So ripple marks that you see here are a feature that is typical of moving water or air. They are small waves of sand that develop on the surface of that sediment layer. The ridges form at right angles to the direction of motion. And if the current only has one direction of flow, they will have a steeper side on the down current side and a more gradual side on the up current side. So those ripple marks with a changing direction of flow are oscillating ripple marks, and they will be nearly symmetrical. So, for example, the bottom right image that you see right here has symmetrical ripple marks where flow of the current was apparently east-west or west-east mostly, if you consider this to be west and this to be east. And for example, the image on the top left over here has ripple marks that have a west to east flow, right? Because the steeper side tends to be on the eastern part, and then the gradual slope tends to be on the western part. Mud cracks are another sedimentary structure indicating that the sediment in which they formed was alternately wet and dry. When exposed to air, the wet mud dries and it shrinks, producing the cracks that we see in the picture on the right, for example. These are associated usually with environments like tidal flats, shallow lakes, and desert basins like the Alvord Basin in Southeast Oregon, which is not too far from here and where you find hot springs. So I did some research there during graduate school. Finally, within the sedimentary structures, we have fossils. Fossils are the remains or traces of prehistoric life. They're important inclusions in sediments and sedimentary rocks. Knowing the life that formed and existed in the past helps us understand the conditions at the time that it made such imprints, or at the time that it perished there, depending on what type of fossil you have. Fossils are also very important time indicators and play a very important role when correlating rocks from different places. We will be discussing fossils in a lot greater detail in chapter 18, so I won't go into too much depth here.